Hi friends, I am Ramya. Today our topic is position, path length and distance. And this is the introduction topic in motion in a straight line. In part 1, we have studied that the change in the position of the object with respect to time is nothing but motion. The object position, when the object position is changing with time, we can say that that particular object is in motion. If the position of the object is not changing with time, is nothing but that object is at rest. So, in order to describe the position of an object, we need a reference point or a coordinate system. In geometry, coordinate system is a method for identifying the location of a point on any frame of reference. In geometry, coordinate system is a method for identifying the location of a position. In order to identify the location of the or position of the point, we must have to use the coordinate system. And frame of reference uses the coordinate system in physics. Here the numbers are nothing but coordinates. This is the origin. Origin means it is the point or place where something begins. We have to take it as origin. And coordinates represent the position of a point along a line. And ordinate is nothing but the number, value. And another word, frame of reference, is nothing but something that is not moving with respect to an observer. Here, that can be used to detect motion. Frame of reference is used to detect motion. In that frame only we can say that that particular object is in motion or moving or it is at rest. Typically here the frame of reference consists of an object or a person that is considered to be stationary. The observer, that particular observer is at rest in the reference frame. Here, let us take this example. Here, the person or observer is at origin. He is stationary. He is not moving. He is in railway station platform. He is observing the train which is moving in front of him. According to this person, the train is moving because the position of the train is changing with time. The position of the train is changing with time. This is the time axis. This is the position axis. This is the position vector which represents the position, where the particular position of that object. This RT is position vector of train with respect to earth. This platform is on earth and we have to assume that earth is stationary. Here we have to consider the object in motion is a point object. In last class we discussed this topic because it is valid only when we take the dimensions of the object. Dimensions of the object means length, breadth, thickness, height, etc. are negligible as compared to the distance traveled by it. We have to take object as a object dimensions are negligible when compared to the distance traveled by that particular object. If we take point object, the pictorial representation will be like this. It is like this. Here, this is the position vector. We have to represent it as R1. It is representing the position of that particular time in this position, and R2 is the position vector of the same train when it is its position is changed after some time. Next, and this is the origin. Here we have to confine ourselves to the study of rectilinear motion, which is nothing but motion of objects are along a straight line. Here x-axis is our coordinate system in one dimension. Here we are taking only rectilinear motion, that is the objects are moving in straight line. If we take this as x-axis, the object position is at origin first at time t is equal to 0, and after some time, after 10 seconds, the object position is here. So we can say that the position is changing with the time, means the object is in motion. And another one more thing, that is motion and rest are relative terms. Relative means comparable terms, comparison. Relative means comparison. Here let us take an example. Ball A is moving 5 km per second and ball B is moving 20 km per second. Relative or compare with B, A is slow. Relative or compare with the A, B is fast. So like this we have to use the relative term. And if we take this stick, it is big or small. We cannot say if it plays alone. When by only putting or keeping another stick with this, then only we can say that it is big or small. If we place this stick along with this, we can say that this stick is big. This means length is also relative. Motion, rest, length, these are all relative terms. By only comparison only one can say that it is in motion or rest, like this. With the comparison of stationary objects only, we can say that the another object is in motion. With the comparison of stationary objects only, we can say that that particular object is in motion or not. Next, here we have to consider another topic, that is path length. Here let us take this boy standing at origin. Consider the motion of the person along a straight line, because here we have to take only straight line and we confine ourselves with this rectilinear motion, because the topic is motion in a straight line. Here let us take 3 points A, B and C, and here origin. B is at 50 meters from origin to B. The distance is 50 meters. From origin to C, the distance is minus 40 meters, because we take it as a x-axis, and this is the x-coordinate system. Now the person starts moving from A to B in first case. Next he moves back from B to C. While moving from A to B, the distance covered by the boy is 50 meters. In second case, the distance covered by the boy is, in second case, he moved back from B to C. So in second case, the distance covered by this boy is BA plus AC. That is BA plus AC. That is 90 meters. 50 plus 40, 90 meters. Here one more thing you have to keep in mind, that C lies at negative side of x-axis. This is the x-axis. If we take like this is the origin. Here we have to take all negative values, but here we are taking positive plus because the distance traveled by a person can never be negative. Distance is a scalar quantity. Scalar means it has only magnitude but no direction. Only magnitude means only value it will take but not direction. This negative sign shows that negative side of x-axis. We are not taking negative direction because direction is not taking, because the distance is a scalar quantity. Scalar is nothing but it has only magnitude but not direction. So the total distance traveled by him is 50 plus 90. 50 plus 90. This is from A to B 50 meters, and from B to C that will be 50 BA plus AC 40 is equal to 90. So total distance traveled by this person is 50 plus 90. Total distance traveled by this person is 50 plus 90 is equal to 140 meters. This is the path length. So path length is defined as the actual distance traveled by an object during its motion in a given interval of time. In a given interval of time, the distance traveled by the actual distance traveled by an object during its motion in a given interval of time. And this path length is also a scalar quantity. In kinematics, there is no difference between path length and the distance, as both refer to the total actual path traveled or covered by a person or object. Both are same, both are scalar quantities. It has only magnitude but no direction. Here this is the B to A distance, A to B distance, and B to C we have to take B to A plus A to AC, that is 90. Total distance he traveled in particular duration of time is this distance, and total this distance we have to add 50 plus 90, we will get 140 meters. This is the path length. Path length and distance both are scalar quantities. It has only value, only magnitude, no direction. Thanks for watching.